Welcome to Chemistry for Big Ol' Babies, presented by Colin Sinclair and
Matthew Boski.
All right. Our special guests are Tristan Powell and Caleb Schlevy.
Hey kids! Hello!
Okay, first we have to talk about the structure of an atom. An atom is made of two parts. The nucleus, it's made of protons, which are positively charged right here, and neutrons, which they don't have a charge. They're a bunch of bums. And then is the electron shell. And can we guess what's in the electron shell?
An electron.
Hey, electrons! All right. Do we know what charge the electrons are?
Negative.
Beautiful, negatively charged.
Wait, actually?
A single atom is known as an element. Elements are differentiated by the amount of protons found in the nucleus. Elements cannot be broken down. They're the smallest unit of everything.
What if you split an atom?
Bad things happen.
There are three types of bonds that can form between atoms. The first one I'm going to talk about is the covalent bond, also known as the molecular bond. In this bond, connections are made by atoms sharing electrons.
There are two oxygen atoms here, and each oxygen atom has 6 electrons. The general rule of thumb for an atom is that it wants 8 electrons in its shell. So when we count how many electrons these two atoms now have, over here we have 1, 2, 3, 4, which it already had, and then 5, 6, 7, 8 in the middle there, forming a full octet on this electron shell. And we have the same thing.
Who says octet?
Chemists. Now, all right, so we have 6 electrons here, and the way we can get to 8 is through something called a double bond. Basically what that means is these electrons right here are going to move into this little part, all right? And then these ones will also do that. So we've got 2 pairs of little X's in there. Ionic bonds.
Ionic bonds form from atoms exchanging their electrons.
We had a sodium atom right here. Sodium has 1 little electron right there. And chlorine has 7 electrons.
So what it'll do is it'll drop that one, give it to chlorine, and then sodium and chlorine both have a full shell.
This end is more positive than this end because the sodium has 1 less electron than it normally does, so it's positively charged.
Advanced.
And then this chlorine atom is now more negatively charged than it would be because that has 1 more electron than it normally does. And these are called ions, hence ionic. All right, and the third type, also the least common of bonds, are metallic bonds. You basically just have like this kind of net of metal atoms because the electrons want to repel each other because it doesn't necessarily create a full shell, and they just kind of float around.
And this floating net of electrons is called the electron seed. When naming compounds, the more electrically positive element, or cation, goes first, and the less positive atom, called an anion, goes second.
So when you name this, you just take the first one here, the more positive one, and you just kind of write it. So we got sodium, and then, also pretty straightforward, we take the second, the anion, and put it down here. But since it's a single element, we change the ending to "ide" to differentiate it from a regular chlorine atom, denoting that it's an ion. With covalent bonds, the cation, in this case H2, also gets a prefix. And since there are 2 hydrogens present, we call it
Dihydrogen. And since there's only 1 oxygen, we call that monoxide.
There are 5 major types of reactions, and the first one we'll go over is called
Single displacement.
single Yeah, single displacement. All right. For example, we have zinc combining with copper sulfate. All right. So basically, what happens here is with the copper ion, and it's going to swap places with this zinc. Copper ion plus zinc sulfate.
It's double displacement, which is fairly similar to single displacement, except both of the reactants are compounds instead of just one.
Silver nitrate here, and we're combining that with your typical NaCl. So we end up with sodium nitrate plus
Silver chloride.
So in synthesis, basically you just have two things coming together from one thing: sodium and chlorine. Sodium chloride. All right, and then we have the opposite, decomposition. So we take, for example, H2O and breaking down to form two molecules of hydrogen gas plus one molecule of oxygen gas. You have one thing breaking down into more things.
Stoichiometry is the balance of chemical equations. The fun part that everyone loves.
Your sodium, and you have your chlorine. But chlorine doesn't like to exist by itself because of how attractive it is. You know, it's just everyone wants it, but it only wants itself. So you're always going to see it in pairs.
Chlorine gas.
Now, to form NaCl like we normally would then, the law of conservation of matter states that matter cannot be created or destroyed. So we need to have the same amount of stuff over here that we do over there. Since we have two of these, we need to be able to account for that over here. So we're going to end up with 2 moles of NaCl. But now the sodium doesn't match up because we have 1 over here and 2 over here. So start with 2 moles of sodium, and that comes together with the 1 mole of chlorine gas, which remember contains 2 chlorines, to form 2 moles of table salt. Any questions, Caleb?
Why do you multiply numbers instead of adding?
So for the same reason you do in math, because simplifying something to like, oh, you have 4 of these or 5 of these instead of 1 of these and 1 of these and 1 of these and 1 of these and 1 of these plus some other stuff. It just helps keep things small. Just real quick, Caleb, what kind of reaction is this?
Would it be decomposition?
Yes! Oh, good job, Caleb. Let's go get you get you a burger.
By the way, Caleb, we are not getting you a burger. Wait, what is this? What? Oh, help! Help me! Yo, can I have an electron?
Sure.
Yo, can I have an electron? Yo, can I have some electrons?
Well, maybe?
Yo, can I have some electrons?
Hey.
Yo, can I have some electrons?
Well, maybe we could share.
They're mine!
No, they're mine!
Hey, what's your charge?
1 plus.
Hey, what's your charge?
1 minus.
Hey, what's your charge?
My what?
Hey, what's your charge? Whoa, cool cat! I'll trade you for mine. Hey, cool cat ion. Why would you do that? Thanks for fixing me up, I guess.
Wow, man, it feels like weight has just been floating off of you. What's your secret?
Oh, nothing.
Wow, man, you've been so much more
Positive lately.
What's your secret?
Oh, nothing.
Wow, man. I think you gave me cancer.
Alright, and who can tell me what Avogadro's number is?
Who is avocado? Also, you spelled yield wrong again?
Remember, element quiz on Friday. Get these terms down.
Did that say pomegranate?
Avogadro.
I call it a mole.
What are you talking about? I didn't even have a graduation or a prom. My summer was ruined.
I think it's half full.
I think it's half empty.
I think it's cake.
You didn't have to come.